All right, moving on to the more examples of the equivalent capacitance. Let's have a look at the next example. So here is a circuit and we need to find out the equivalent capacitance. So remember, we will use the same approach like we did in the previous cases. Okay, like whenever we want to find the equivalent capacitance, for example, between these two nodes, we will start from the end of the circuit. Okay, so if you look from the end of the circuit, now to make it more easier, like we did in the resistive circuits analysis, we will label the nodes, okay, to make it easier for our calculation. So like this is a complete one node, let's call this node A. This is one node, let's call this node B, right? This is another node, okay, the same one, let's call this node C. Okay, so if I look at this circuit now, I can see that basically this 2 microfarad and 4 microfarad, they are sharing two nodes, right? They are sharing like the node A and they are sharing node B, so it means they are in parallel, right? So in the capacitance case, if the two capacitors are in parallel, their net capacitance will be, just add them, right? So this 2 and 4, that will basically become what? 6 microfarad. So it means if I redraw the circuit, okay, at this point A, I can represent this with the one capacitor of 6 microfarad, right? And then this is point, like this is node A, this is B. At B we have another 3 microfarad. And lastly, between A and C, we have another 2 microfarad, right? So again, like this was my node A, this is my node B, and this is my node C. And here we have basically another capacitor of 12 microfarad. Okay, so this is why will be kind of a redrawn circuit for this case. Now if you look at this one, this 6 and 3, what they are doing, they are in series, right? If they are in series, how we calculate their net? Okay, so their net will be 1 over 3, okay, using parallel, right? If they're in series, parallel approach. So 1 over 3, 1 over 6, that will give me basically how much? 2 microfarad, right? So it means if I further redraw this circuit, okay, this is 3 microfarad, so that will become like this one, 3 microfarad, and then here I have how much? 2 microfarad, and then again here I have another 2 microfarad, right? This one, and this is my 12 microfarad, right? Now what is happening? Here we can notice that basically this 2 microfarad and this 2 microfarad are in parallel, right? They are in parallel. It means this circuit can be further simplified to this form, like this 2 parallel can be replaced with 1. What will be that? If they are in parallel, we just add them, right? So 2 plus 2, 4 microfarad. So here we have 3 microfarad and here I have 12 microfarad. So what will be the net now? All these three are in series. So that will be 1 over 3 plus 1 over 4 plus 1 over 12, okay, whole inverse, right? So this comes out to be basically 3 over 2 microfarad. So the equivalent capacitance for this case from this end is basically 3 over 2 microfarad. So remember the approach is same. Start from the end of the circuit. If they are in parallel, capacitors are in parallel, we just add them together, okay? And if they are in series, like these two, we just use the inverse approach, okay? And this way we can just simplify this circuit to get the net equivalent capacitance. Thank you so much.